In the place where smoking is most strictly forbidden on an aircraft, an ashtray still sits in plain sight. It appears beside warnings stating that the very act associated with it is completely prohibited. Hundreds of passengers may share one sealed cabin where smoke and fire cannot easily escape. Directly below the ashtray, the waste bin often holds paper towels, tissues, and other easily ignited materials. A cigarette that appears extinguished can still smolder long enough to turn paper waste into a fire source. By ordinary logic, once smoking was banned, anything made for cigarettes should have disappeared. Keeping it seems outdated and contradictory to the entire safety message of the passenger cabin. But without that safe disposal point, a rule-breaking passenger could still carry a cigarette on board. Afraid of being discovered, that person might choose the waste bin instead of a safe metal surface. After the door closes, a tiny ember could continue burning where no one can see it. Yet the small ashtray remains, inspected and replaced on many aircraft still in service. It was not designed for obedient passengers, but for the moment someone decides to act wrongly. It is a safety trap that cannot stop stupidity, but can keep its consequences within limits. The object at the heart of this paradox is the ashtray mounted near a modern aircraft lavatory door. It stands against human behavior in a struggle where one small mistake can threaten an entire sealed cabin. To understand this outdated-looking object, the story must return to an era when cigarette smoke was normal on board. For decades, passengers could smoke in their seats, sometimes only one row away from non-smokers. Ashtrays then appeared in armrests, cabin walls, and many convenient places for extinguishing cigarettes. The cabin was not considered completely smoke-free, but a space where existing smoke had to be managed. Yet the lavatory was always more dangerous because it was small, hidden, and filled with disposable paper. The crew could not constantly watch a locked room where a heat source could be hidden within seconds. A cigarette thrown into the trash did not need to ignite immediately to become a serious threat. Smoldering could develop slowly, producing smoke before flames became large enough to be seen. In a building, people can move away from a fire. In the air, the entire room keeps moving with them. Toxic smoke can also spread through the cabin, reducing visibility and complicating emergency response. So the problem was not only discomfort from smoke, but the danger of disposing of a heat source incorrectly. As health awareness changed, smoking sections shrank and gradually disappeared from commercial flights. Prohibition signs became clearer, crew announcements became firmer, and smoking violations were treated more seriously. Yet a ban did not instantly remove cigarettes from luggage or erase long-established human habits. Some people still violate the rule because of addiction, carelessness, stress, or faith in a locked door. Aviation, therefore, had to confront the uncomfortable gap between what rules require and what people actually do. If a design works only when everyone obeys perfectly, it fails the moment the first person breaks the rule. That is why many cabin details remain, not because of correct behavior, but because of the consequences of wrong behavior. The ashtray survived the smoke-free era for a reason opposite to its original purpose. It once supported smoking. Now it exists to limit damage when smoking still occurs. The first response was simple: place a small metal container where a violator would see it immediately. Metal does not ignite easily, withstands heat better than paper, and isolates cigarette waste from nearby materials. Its small recessed chamber reduces the chance of a cigarette touching airflow or rolling onto something flammable. Its location near the door lets a frightened violator extinguish a cigarette before facing the crew outside. The solution requires little thought. It simply places the least dangerous option within immediate reach. This reflects a central safety principle. Under stress, the safer choice must be clearer than the mistake. But one metal box alone cannot protect a tiny room from every way a person might fail. Warnings on the door try to stop the behavior before a heat source enters the hidden space. Crew announcements remind passengers that a locked lavatory is not a private zone beyond safety rules. Waste bins were sealed more tightly, so a small fire would receive less oxygen and spread less easily. The hinge and latch became safety components, even though passengers usually see only a trash bin flap. Smoke was no longer left for human eyes alone. Sensors were assigned to detect it earlier. An automatic extinguisher was added to respond inside the waste bin if heat reached a dangerous level. The room gradually gained layers: prevent the violation, contain the cigarette, detect smoke, and suppress fire. Each layer assumes the previous one may fail, because a warning cannot guarantee universal obedience. The ashtray was no longer an amenity. It became one link in the cabin's fire protection chain. Its removable design allows cleaning staff to empty ash and inspect the container after a flight. Removability also allows quick replacement when the ashtray is damaged, jammed, or missing. A tiny detail therefore creates inspection procedures, spare parts, and clear maintenance responsibility. From one metal container, Aviation gradually built a backup system designed around human error. As aircraft became more complex, fire protection could not depend on each airline making its own choices. Design requirements turned ashtrays, waste bins, and sensors into components that had to prove themselves through testing. Engineers examined not only materials, but also placement, visibility, and how easily passengers could reach the device. An obscured ashtray is nearly useless when a violator has only seconds to dispose of a cigarette, so it is placed prominently on or near the side of the lavatory door passengers see when exiting. In some layouts, one ashtray may serve several doors if it is clearly visible from every entrance. Regulations do not assume a calm violator. They assume behavior may be rushed, secretive, and irrational. This is design based on real human behavior, not the idealized person imagined in a manual. In the United States, certification standards still require a self-contained ashtray placed prominently near the lavatory door. That requirement remains despite the smoking ban because it addresses the moment the ban fails. The FAA has emphasized that the ashtray serves an important safety function, not a decorative one. An ashtray missing because of damage or accidental removal can become a maintenance issue requiring follow-up. An aircraft may sometimes operate temporarily under specific conditions, but the missing part must be replaced on time. Its value, therefore, comes not from its size, but from its place within the larger fire protection system. The waste receptacle must also contain a possible fire under real conditions of use and wear. Designers must account for misaligned hinges, incomplete closure, dirt, and damage accumulated over many flights. Routine inspections, therefore, check not only missing equipment, but whether the waste door closes and seals properly. Cleaning staff become an early warning line when they notice ash, unusual odors, or scorch marks after a flight. Cabin crew inspect lavatories in flight, watching for smoke odors, sensor alerts, and unusual passenger behavior. If a sensor activates, the crew must respond quickly because even a few minutes can worsen the situation. The cockpit must also be informed so pilots can assess the danger and prepare an appropriate landing plan. The ashtray therefore connects passenger behavior with maintenance, crew training, and operational decisions in the cockpit. A strong safety system treats human error not as a rare exception, but as a variable to manage. That is why cabins use many small barriers instead of placing complete trust in a single prohibition sign. When these layers work together, the safety trap acts before, during, and after a violation. To understand the ashtray's importance, look at what remains after the visible flame appears to be gone. The glowing charcoal core can retain heat, even when the outer surface looks cold and gray. When a cigarette touches dry paper, heat moves into the fibers and begins a smoldering process. Smoldering needs no large flame. It consumes material slowly and can survive in dark, hidden spaces. Each time the waste flap opens, fresh air may enter and feed material that is already hot. If the door closes tightly, limited oxygen gives the container a better chance to hold the fire inside. But if the flap remains open, continuous airflow can remove the crucial advantage of a sealed compartment. That is why even a tiny spring in the waste flap is inspected as part of the fire protection system. The ashtray solves the problem earlier by keeping the cigarette out of the paper, oxygen, and smoldering chain. Its metal surface absorbs heat from the cigarette and spreads it over a wider area, cooling the hot spot. The recessed chamber keeps ash and cigarette remains from rolling out during vibration or changes in aircraft attitude. A closing lid or door further separates any remaining heat from hands and nearby cabin materials. Its self-contained structure also prevents ash from falling into wall gaps where heat and smoke are harder to detect. If a hot fragment enters the wall, the crew may smell smoke but struggle to locate the source. A visible fire is often easier to fight than smoldering hidden behind panels and equipment. So the first strategy is always to keep the heat source somewhere visible and accessible. If heat still reaches the waste bin, the smoke detector becomes the next layer, shortening detection time. The detector does not need to know the cause. It only needs to recognize a worrying change in the environment. The alarm moves the problem from a locked room to a place where the crew can begin acting. Inside the waste bin, an automatic extinguisher can respond before a crew member opens the compartment. This mechanism does not replace the crew. It buys time for people to confirm and control the situation. The crew must still inspect the source because reduced smoke does not mean every hotspot is gone. Smoldering material can retain heat, so the area must remain under observation after visible smoke stops. If fire is still suspected, the aircraft may need to change plans rather than continue normally. A single cigarette can therefore influence decisions from the lavatory door all the way to the cockpit. Yet the most important mechanism is not metal or sensors, but the way design anticipates human choices. A person hiding a violation usually wants to remove evidence faster than follow a careful safety procedure. In that state, the safe option must be close, obvious, and usable without opening extra doors or compartments. The ashtray acts like an emergency exit for a bad decision, even though it cannot erase the violation. It does not protect the violator from legal consequences. It protects others from the physical consequences. This is the difference between encouraging a behavior and reducing harm when a banned behavior still occurs. Aviation describes the wider idea as fault tolerance. The system keeps protecting people when one link fails. A warning may be ignored, and the ashtray may be ignored, but the detector and sealed bins still wait. If the sensor fails, smoke odor, crew inspections, and passenger observations may still reveal the problem. No layer is perfect, but all layers failing together is far less likely than relying on only one. This is why aircraft contain details that seem unnecessary until normal conditions stop being normal. The ashtray cannot stop someone carrying a cigarette into the lavatory, but it can change where it ends. A small change in disposal location can separate one personal violation from a cabin-wide alarm sequence. The ashtray's true value therefore exists in the scenario nobody wants, not during ordinary operations. It is like a trap left open, waiting to catch the consequence before it reaches the waste bin. But keeping an object associated with smoking creates another paradox. Passengers may misunderstand its purpose. Some people take its presence as proof of an exception, even though the truth is exactly the opposite. Designers must balance making the ashtray visible without making it look like an invitation to use it. If it is too discreet, a frightened person may miss it. Too prominent, and others may misread the message. That paradox is why warnings, prohibition symbols, and crew training must exist beside the backup device. The ashtray also creates maintenance work because it can become jammed, dirty, damaged, or removed. A lid that will not close can spill ash, while a full container may send a violator elsewhere. So a rarely used backup device must be maintained as though it may be needed tomorrow. Removing or changing it is not simple, because the cabin configuration was certified as a complete system. Taking out one component may require reassessing placement, materials, fire risk, and related maintenance documents. A tiny change to a lavatory door can trigger testing, approval, and updates across several technical procedures. That is why many aircraft retain older designs when changing a proven certified configuration offers little benefit. Yet changing technology and behavior have led some regulators to reconsider whether every design still needs an ashtray. EASA has allowed some new aircraft designs to omit an ashtray inside the lavatory under updated requirements. But existing fleets often retain it because they were certified under earlier standards and configurations. This creates mixed fleets where passengers may see an ashtray on one aircraft but not another. That difference does not prove one aircraft safer. The safety of the complete certified system matters. Another modern risk appears when passengers use vaping devices and assume they cannot trigger an alert. Vapor, smoke, and concealment can still cause alarms, disputes, and time-consuming crew investigations. Every false or uncertain alert consumes attention needed for many other cabin safety duties. More seriously, a violator may try to cover or interfere with the detector, removing a critical detection layer. That is why tampering with warning equipment is treated as serious misconduct, not harmless mischief. The more layers a system has, the more complex maintenance and training become, yet removing layers reduces fault tolerance. The price of backup safety is maintaining equipment that almost never serves its original purpose. But that price becomes clear only when one passenger turns a small room into the starting point of a crisis. Imagine a normal night flight when most passengers are asleep and the cabin is nearly silent. A tense passenger leaves the seat, walks to the lavatory, and locks the door while crew work ahead. The person deliberately breaks the rule, believing a few private minutes will be enough to avoid detection. Then an approaching service cart causes panic, and the violator hurriedly searches for somewhere to discard the cigarette. The ashtray is beside the door, but in panic, the person still throws the cigarette into the paper waste. The surface appears extinguished, yet a tiny hot core remains buried among layers of dry tissue. The violator washes their hands, leaves, and returns to the seat before visible smoke appears. Inside the bin, heat slowly spreads into paper, forming a smoldering area smaller than a coin. Small gaps around the flap admit air while paper above hides the hot source from view. Several rows ahead, the cabin remains quiet, unaware that a dangerous chain has begun. When the first smoke rises toward the ceiling, the detector senses the change before odor spreads through the cabin. The alarm reaches the crew area and breaks the silence in a single moment. A flight attendant approaches the lavatory, checking heat, odor, and whether anyone remains trapped inside. Another crew member retrieves protective and firefighting equipment while information moves quickly to the cockpit. Inside the bin, the automatic extinguisher responds to heat and slows the process before fire spreads. But the crew cannot assume the danger is over because heat may remain beneath paper or behind a panel. The cabin wakes. Passengers notice an unusual odor, and anxiety spreads faster than the thin smoke. Pilots must decide whether the fire is controlled or the aircraft should land at the nearest suitable airport. An act lasting only minutes can change the route, schedule, and emotional state of hundreds of people. If the cigarette had entered the ashtray, the chain of paper, smoke, alarm, and diversion might never form. The small device cannot stop the violation, but it can completely change the scale of its consequences. This hypothetical scene shows that danger begins not with a large flame, but with one wrong disposal choice. Because smoking materials have caused aircraft fires before, safety authorities treat ashtrays as necessary equipment. The greatest threat is not fire alone, but toxic smoke and heat reaching important aircraft systems. In a place that cannot be evacuated mid-air, keeping one ember out of the wrong place is far cheaper than fighting a fire. After an incident, the response does not end when smoke disappears. The area must be inspected before the next flight. Maintenance staff look for heat damage, smoke staining, damaged wiring, and pathways that could let fire spread. The waste bin is removed, the flap and latch retested, and the automatic extinguisher restored to readiness. The ashtray is also checked to confirm it is present, clean, accessible, and able to contain hot material. Crew reports help determine when the alert occurred, what odors were observed, and what actions were taken. The goal is not only to assign blame, but to verify whether the system responded as designed. If the warning came late, the detector, airflow, and installation position may need reconsideration. If the waste flap failed to seal, hinge design, inspection schedules, or cleaning procedures may be adjusted. If the ashtray was obscured, service cart placement and cabin equipment layout may also need revision. Crew training uses simulated smoke, so a complex response becomes a familiar sequence of actions. The goal is not heroism, but reducing hesitation when an alert appears under intense pressure. Communication with the cockpit gives pilots practical information instead of only a single alarm signal. Pilots combine crew reports, remaining flight time, and suitable airports to choose the safest option. After landing, ground personnel can inspect from outside, where equipment and escape routes are less restricted. The violator may face consequences, but the technical lesson focuses on preventing a similar error from causing greater harm. Incidents and maintenance findings accumulate into data that helps aviation refine standards over time. A repeated failure may lead to tighter inspections, different materials, or a required design change. The ashtray lives within that cycle: design, operation, fault discovery, modification, and return to service. It is not a forgotten relic, because relics are not inspected, replaced, and recorded as safety equipment. Each inspection reminds the system that it must remain ready for behavior everyone hopes never occurs. The most common misunderstanding is that the ashtray means smoking is allowed if the cigarette is disposed of properly. The truth is the opposite. Smoking is banned, and the ashtray exists for the person who disobeys. It resembles a kitchen fire extinguisher. Its presence does not permit fire, but prepares for one. Another misunderstanding is that it remains only because manufacturers were too lazy to redesign the cabin. On many aircraft, it remains part of the certified configuration and the scheduled maintenance program. Yet it is also inaccurate to claim every modern aircraft worldwide must carry the same kind of ashtray. Standards, certification timing, aircraft design, and regulatory jurisdiction can produce different configurations. Some new designs may omit the interior ashtray, but the complete fire protection system must still meet requirements. What matters is not counting ashtrays, but understanding how the system manages heat, smoke, and violations. A third misunderstanding is that an aircraft cannot burn because every cabin material is completely fireproof. Fire-resistant materials slow development, but paper waste, personal items, and heat sources still create real risk. Safety does not mean fire is impossible. It means ignition is harder, detection earlier, and control more effective. The modern turning point is moving from hoping people never fail to designing systems that can tolerate failure. The ban remains essential, but it is the first preventive layer, not an impenetrable wall. Good design asks an uncomfortable question. If someone deliberately breaks the rule, how far can the consequences travel? This is not pessimism. It recognizes that people become tired, addicted, frightened, distracted, and sometimes defiant. Rather than denying those weaknesses, engineers turn them into data for placement, materials, and protective layers. The same philosophy appears across the aircraft, from door locks and oxygen masks to alarms and backup mechanisms. Every device assumes another component may fail, be misused, or not work at the right moment. Removing a detail is justified only when a new system proves equal or better protection. The future may change the form of ashtrays, detectors, and waste bins, but the backup principle will remain. Better sensors may detect danger earlier, but technology should never justify ignoring human behavior. More fire-resistant materials reduce risk, yet they must still work with detection, containment, and crew response. Technology does not replace rules. It protects obedient passengers from harm caused by one violator. That is the reversal. The ashtray belongs not to the age of smoking, but to the age of risk management. It exists not because the rule is weak, but because safety is serious enough to prepare for broken rules. When the flight ends, most passengers leave without ever noticing the small metal box. It remains unused and silent, and that silence is the best outcome the design can receive. The safety trap catches nothing, yet waits for the moment one foolish decision appears. Because good safety does not merely trust people to do right, it prepares for the day someone does wrong.